out on your desk. That's up on the chalkboard. Ready to go. I'm starting. You're not ready, you're behind. So we're going to finish. All right, I got to start writing people tardy on this. I want you to keep in mind, 3 tardies, you get a detention. Detention. That is in your code of conduct that you sign off when you become a student at this school. That's like an after-school detention, yes. I'm not debating, I'm just telling you what the rules are. They have not changed in the 27 years I've been here. I don't understand why we're talking. I've given instructions that those are the 5 items you should have out on your desk. Do we want to learn how to finish these kinds of problems with a ruler and a protractor, or you just want to do it yourself? Google how to do it and figure it out. I don't think so. That's a guarantee that you'll probably lose 10 points off the Regents exam because they're not showing you how to do it the way New York State requires you to do it. Page 5, ruler and protractor questions. Your homework is pages 7 through 9 for Monday. Okay, on page 5, question 8, we have a child who's riding their bike from their home to their friend's house, and they take a route which takes them 40 point meters to the east and then 40 point meters at 45 degrees. First thing I want to know is how much distance they travel. To determine distance, what are we going to do? Eric, can you tell me? How are you going to determine it was my question. No. That is not what we're going to do. There's no calculations. No referencing stuff. This is all ruler protractor stuff. But distance doesn't require anything new. This is a review question. Yeah, you're just going to add the values together. Because distance is a scalar measurement. 40.0 meters plus 40.0 meters. So what is the distance traveled, Logan? Nope. That would not be marked correct on a test. Thank you. 80.0 meters. Remember, when we add, we keep precision. Now, next thing wants to know the displacement. Displacement's a vector, and this is not going to be a right triangle. We do not use any equations to do this. Not one. If you start writing a squared plus b squared equals c squared, you're not going to get anything close to the right answer. You need your ruler and your protractor to do this. Without this, you're not going to be able to solve the question. Not unless you want to use laws of sines and cosines to do this, which I don't plan on teaching or having you use in this course. That's not part of the course requirements. Ruler and protractor is. The first thing you have to do when you get a question like this is look at the 2 individual vectors that are creating the net displacement. One is to the east and one is at 45 degrees. So if you think about somebody traveling east and then moving at 45 degrees, you need to ask yourself first and foremost, in what quadrant are they going to end up? Quadrant 1, that's right, because east is to the right and 45 degrees is up and right. So here's what we have to do next. This is a drawing problem, and I'm going to give you a scale. Don't worry about the scale yet. What we need to do is draw in our x-axis for the question. And foreshadowing, knowing that this is in quadrant 1, helps us figure out where we're going to put the x-axis for the space, because we do not want to run out of space in our answer area for this question. We're going to travel to the right, and then we're going to go up and right at 45 degrees. Based on that and our answer needing to be in quadrant 1, I'm going to put my x-axis towards the bottom of the answer space. If I put it too far up, I'm going to run out of room and end up on top of the words that are here. If I put it even in the middle of the space, I'm going to end up going over the text, and that's not what I want. I want to use the answer space to draw this out. So with your ruler, please draw a nice horizontal line here and label that positive X. That is the positive X direction. Thank you. And that positive X, remember, is equal to 0 degrees or east. Notice I do put an arrowhead on it, defining that as our east direction on our page. The next thing you have to do is, again, think about the directions this person is moving. They're going east and then 45 degrees into quadrant 1. I need to put an origin on this line. And again, I don't want to run out of space, which means I'm going to put the origin towards the left side of this line, so that way I'll be drawing up in here. If I make this too far to the right and I go east and then up and right, I'm off the page. You follow what I'm saying? So I need you to think ahead. Where are you going to put your positive x-axis? And where are you going to put your origin? Now, we're going to start by drawing out to scale our first leg of the trip. 40.0 meters east. East is to the right along this line. In this scale, every centimeter represents 10 actual meters in real life. So if I need to represent 40.0 meters in this scale, the line segment I'm going to draw will be 40 divided by 10, or 4.0 centimeters of length. Let me show you how we do that. We are going to start at the origin that we marked on our page. That is our 0. And now I'm going to measure out to exactly 4 centimeters, which is here on my ruler. I'm going to make a little dot on the line at exactly 4 centimeters. Can you all do that with me, please? Measure it out, exactly 4.0 centimeters. Make a little dot on that line, 4.0 centimeters away from your starting point. Okay, now take your ruler away. I want your all eyes up on the screen. Every little thing that you measure even a little bit imprecisely, you're off by even a millimeter, is going to guarantee that you don't get the right answer at the end. So the best thing we can do now, eyes up on the screen, is look at how we add an arrow to this so we do not change the length of that vector. We're going to put our pencil, I see a lot of eyes not on the screen, up here. Watch how we do this to make sure we get the right answer. We put our pencil at that dot and we pull back to add the arrowhead. So that way we make sure we are not adding length to the actual vector. Adding even 1 millimeter of length because you're doing it sloppily or not carefully will ensure you don't get the right answer at the end. You have to do this very carefully. These are not questions that you do quickly. We are now going to measure label the length of that arrow, not in centimeters. That arrow is meant to represent 40.0 meters. And I don't have to label the direction because it is pointing right, which we've already said is east. Is everybody with me right now? Okay. The next one is harder, and it requires use of our protractor. And I know you're not taught how to use a protractor before this class, so I need to go over how to use this. So everybody needs theirs out. Without it, you're going to have to watch the video and then replay it in slow motion probably. We're going to start by looking at a protractor to understand where certain things are. The first point everyone needs to identify on their protractor is their protractor's origin. Your origin is in this vicinity. My protractor has a crosshatch at the origin right here. Yours may not. It might have a little hole in your protractor. That's your origin. That origin is going to get placed on top of the tip of this arrowhead. This line to the right is 0 degrees. Now, your protractor has two sets of markings on it. You see you have a set of markings on the inside and a set of markings on the outside. Doesn't matter which one we use. We're not using the actual numbers that are there. We're using them to measure numbers between where we're starting and ending. I'm getting ahead of myself, but I want you to put this protractor's origin at the dot where we ended the last vector. You can see where I have it on mine. Go ahead and put yours there. I want to make sure everybody has it placed correctly. Otherwise, the rest of this is going to get botched. You're jumping ahead. You have not taken this class before. So do not jump ahead. Just place it where it needs to go. Well, you lost 10 points off the reasons. You have to come prepared to class. You had a month. We got to get on the ball. Same thing. Got to get on the ball. This isn't even straight. Where's your rule? I got to remember your daily grade is for not only being on time and having homework done, but coming prepared to class. If you're not coming prepared to class, you can't learn the material. I'm just disappointed. That's the worst thing that a teacher can be, is disappointed. Just like if your parents are disappointed in you, that's like the worst thing I can say to my daughter, is that I'm disappointed. That is not the level of student that we expect in this class. You're not freshmen anymore, guys. You're young adults. If you expect adults in this building to treat you like young adults, then you got to show up prepared. Your primary job in this class is to be a student. And half of you don't have it. How am I supposed to teach a topic that involves a ruler and protractor if you're not prepared? This is guaranteed. I saw your Regents exam in June. I saw it. I wrote half the questions on your test. I've seen it 6 times already, editing it to make sure it's good to go. There's one more review next month, and I'll be there next month to make sure that they have every period that's supposed to be there, every symbol that's supposed to be there is there, that your answer sheets are laid out properly so you have enough room to do the work. This is on there. If you're not prepared in class, you can't learn it. I don't go home with you to remind you to do things. That's why things are posted in Google Classroom as announcements. And if you are not bothering to look at it or to write it down, then you have no business being in this class. Please go see your guidance counselor and ask to be dropped and a schedule change. I don't have tolerance for this. And I don't want to have to talk to you like this every day. It does not make my job an enjoyable one. I usually love my job because my students are ready to go. They want to learn. They're the most motivated students in the building. If this is the most motivated we have, your generation is in trouble. I'm not going to lecture anymore. That's it. You don't have it? Just sit back and watch. You can watch the video this weekend once you have materials and try to catch up. It's your grade, not mine, but you will be getting a 0 for today's lesson because you are not prepared. So what we do now, as I mentioned, there are 2 sets of degree markings on this protractor. This is 0, but this can also be 0. This is the 0 we need because this is the east. And according to the protractor or the directions, we need to measure out 45 degrees from our reference here. So I'm not going to use the outer markings because the outer markings start at 180 and then go to 170 and so forth. That's not what I want. I need 45 45 would be halfway between the 40 and 50 mark here. This is 5 degrees above the 40, so I'm going to make a little dot at 45. So those of you with your protractor, go ahead and make a little dot at 45. You're going to erase that dot in a minute. We're going to remove our protractor. We don't need it till the very end of the question again. We're now going to measure out the length that we need going from this point in that direction. That is 40.0 meters. In this scale, that will be exactly 4 centimeters. So we go back with our ruler. We line it up from the tip of the arrowhead that we drew, and we put our ruler going in the direction of that dot. We line it up as carefully as we can, or our measurement will be wrong. We're going to start here at the 4 centimeter mark. We don't start at the dot. We start at the 4 centimeter mark, and we go back to draw in that line segment. The reason we do that is because we want to make sure we're not drawing a 4.1 centimeter line segment. That would be wrong, and our final answer would be incorrect. We take our ruler away. We go to the tip of this line segment with our pencil, and you're going to pull back to make your arrowhead. You're now going to use your eraser to erase that reference mark we made at 45 degrees because we don't want it in the space. We're going to label that arrow. 40.0 meters, comma, 45 degrees. Now we're going to draw in the actual displacement vector. It goes from our starting point to the tip of that arrow. Now you're going to do it in pencil, but I want to make sure you understand which one is the displacement vector. So I'm going to make mine stand out in red pen so you can see it. We're going to use our ruler to connect the start and end points. And we draw in that line segment. It's not done because it needs to be a vector, which means we're going to put an arrowhead on the tip of this the same way we did the others. We put our arrow at the tip and we pull back. This is our displacement vector, so we're going to label that D with the arrow. And now we have to determine what that answer is. The first thing we're going to do, which is the easy part, is measure the length of that displacement vector with our ruler. And when I measure it, hopefully you're getting the same thing. I get 7.4 centimeters. Are you getting 7.4 centimeters of length? Okay. Assuming you've measured it correctly, you get 7.4 centimeters. You're never going to write that down anywhere. No one cares how many centimeters it is. I need to know how many meters that represents. What is this child's actual distance from start to end point? So in this scale, 7.4 would be 74.0 meters. We're going to keep the same precision of the individual values that the scale gives us. So off to the side, we're going to say that the displacement is 74.0 meters, comma. That's the length or its magnitude from here to here. Now we use our protractor again to determine the direction. We can't calculate it. It's not a right triangle. If you tried using a squared plus b squared equals c squared, you don't understand what a right triangle is. It's not any old triangle. That is not a right triangle. There's no 90-degree angle in there. We're going to put our origin at the original origin. Imagine you do not see these two arrows at all. You don't see them. All we have is that displacement. We're going to put our protractor back, line it up with the reference line. And we are going to measure the size of the opening from the 0-degree reference up to that displacement. What is the size of that arc right there? That's the direction we need that we learned about yesterday. So when I start here and I go up, I'm getting 22 degrees. Are you getting 22 when you do it? Okay, good. That's what you want. You get 2 degrees of leeway. So that means I would take answers between 20 and 24 degrees, but I can guarantee you if you're not doing this carefully, you're not going to get either the right distance measurement part of the displacement and you won't get the correct angle. So I'm going to indicate my displacement and I box it in. This is a quadrant 1 problem. We're now going to tackle 2 others. Number 9 says a group of friends is hiking in the Catskill Mountains. And you're going to take a trail which goes 30.0 meters to the west and 50.0 meters at 210 degrees. First thing I want to know is how much distance your group traveled. So remember, distance is a scalar, so all we do is we add those amounts together, 30.0 meters plus 50.0 meters, and that's going to give us what for an answer? 80.0. We keep the precision when we add 80.0 meters. Now, the next part asks about the group's displacement, which is a vector. Before you draw anything, you have to figure out what quadrant is the net displacement going to be in. This group of friends went west and then 210 degrees. What quadrant is that group of friends going to end up in? 3, that is right. In quadrant 3, that means you are below the x-axis. So if we think about where we want to place our x-axis, so we have all of this space to use to draw it out, where do you think we should put it? At the top of that answer space. Very good. Let's use our ruler to draw our x-axis towards the top of the space. Put an arrow here, label that positive x, which again is 0 degrees and east. That is our reference. Now, again, I got to figure out where am I going to put my origin in this question? Well, this group is going west first. West is left. And then 10 degrees is down and left. So that means I'm going to place my origin on the right side of this line so that way I don't run off the page on the left side. Now I'm going to measure out the first one, 30.0 meters west. That's along this line. In this scale, 30.0 divided by 10 would give me exactly 3 centimeters. So I'm going to make a mark on that line at exactly 3.0 centimeters right here. It's a little dot, itty bitty. There's my 3.0 centimeter mark. Now I'm going to put my pencil at that mark and I'm going to pull back to create the arrowhead. We label it 30.0 meters. I don't have to say west. I just defined that direction as east. So obviously, that's opposite of that, which is west. Now I have to do 210 degrees, which is down here. And we have a little problem with our protractors. Because the way our protractors are designed, if you have these half circle ones, we can only go from 0 to 180 degrees. We got to go beyond that. How many degrees beyond 180 are we going? 30. So please turn your protractor upside down. Place the origin at the tip of that 30.0 meter vector. Line up your 0, 180 degree marks with the reference line. And we're going to measure 30 degrees from here because this is 180. So that's 180. We would then count 190, 200, 210 would put me right here. Little dot at that 30 degree, 210 degree mark. Now we're going to measure out 50 meters going from here to here. And when I do that, I can see in the scale that will be exactly 5.0 centimeters. So I'm going to line that up. Get it to go in that direction. Starting here, I want to make sure I get to exactly 5.0 centimeters. I'm going to add that arrowhead here at the tip. And I'm going to erase that little extra dot at the 210 degree mark. We're now going to label that. That is 50.0 meters, 210 degrees. Next step is to draw in the displacement vector, which goes from our starting to our ending point. So with our straight edge, we're going to connect those 2 points with a nice line segment that does not go beyond either of those 2 points. And we ended up here, so we add an arrowhead at our ending location. This is our displacement, which we are looking for. The first thing we're going to do is measure the magnitude of that arrow. So when I do that with my ruler, I'm getting 7.8 centimeters. Does that sound like what you're getting? 7.8 centimeters. Yes? Yes? Okay, so 7.8 centimeters in this scale. means that my displacement would be 78.0 meters. Now I got to come up with the angle. We ignore the 30 meter and the 50.0 meter vectors. Ignore them. We take our protractor. We're going to put it upside down at the original starting point. And we're going to measure the size of the opening from here to here. I'm getting 19 degrees when I do that. Are you getting 19 from here to here? Yes, good. Okay. The answer isn't 19 degrees. From here to here is 180. We got to go beyond it by that 19 degrees. So that means my angle would be 199 degrees. 180 plus the 19 I just measured. That is in quadrant 3, between 180 and 270 degrees, so that's good. You get 2 degrees of leeway, so I would take angles between 197 and 201 degrees. If you're off by more than that, or you're off by more than 0.2 of a centimeter, which is 2 meters here, that would cost you credit. It means you did not draw it carefully enough. Questions? Yeah.
So is it the margin for the second variable and not the first one?
Both. This one is plus or minus 0.2 of a centimeter. So in this scale, 0.2 of a centimeter would be 2 meters. So I would allow an answer between 76.0 and 80.0 meters. If you're outside that range, you lost credit. And 2 degrees on the angle. Okay? That's always the tolerance. Always. Okay? That's why it's so important to do this carefully. Because even 1 millimeter off or 1 degree off when we're doing individual things can be exacerbated as you have multiple ones that you're drawing out. All right, number 10 is the most challenging one. And there's a lot of tips and tricks I have to give you for this one. It says that we have a grizzly bear looking for food. It takes a path which goes 15.0 meters to the east, 20.0 meters to the south, and 25.0 meters at 300 degrees. The first thing I want to know is how much distance the grizzly bear is traveling. So to determine the distance, we're going to take 15.0 meters. We add it to the 20.0 meters, and we add that to the 25.0 meters. What does that mean? The distance traveled by this grizzly bear is 60.0. There you go. Got to keep the precision. 60.0 meters. Now I want the displacement. So again, you got to ask yourself, where is this bear going to end up? In what quadrant? It's going east, then south, and then 300 degrees. Brody? Yes, very good. This is a quadrant 4 question, which means, again, we're always going to be below the horizontal axis. So we should place our horizontal axis towards the top of the space for this problem. This is our positive x direction, which again represents 0 and east. Now, since we're going to be in the 4th quadrant, that means we're going to put our origin towards the left side of this line, so that way we don't run off the paper on the right, because we're going to go right, we're going to go down, and then we're going to go down and right. The first one we do is the horizontal one, 15.0 meters east. In this scale, how long is it going to be? 15 divided by 5 is 3, exactly 3.0 centimeters. Starting at our original point, we make a mark at 3.0 centimeters, and then we add our arrowheads to that, pulling back. We label it 15.0 meters. Okay, you cannot eyeball south. South is 270 degrees. So we have to turn our protractor upside down at this point, and we have to line it up to be here at the 90-degree mark below the x-axis, starting at the tip of that 15.0 meter vector. You got to line that up, make a mark. It has to be exactly south. If you did it at 91 or 89 degrees, now you've got an error, which could cause your final answer to be off. So again, you turn your protractor upside down, line it up at that tip of the vector we just drew, and you want to go 90 degrees in the southerly direction because that will be 270 from the positive x, rotating all the way around to go down. Now we have to measure out 20.0 meters in this scale. 20 meters in this scale would be how many centimeters? 4, right? 20 divided by 5 is 4. So we're going to measure from the tip of that arrow in the direction of the dot we just placed on our paper, and we're going to measure out exactly 4.0 centimeters. We had an arrowhead. We label it 20.0 meters. That is south because we define that to be east, and we erase the reference dot that we just made. All right, the last one is the hardest one again. And I just want to review with you something. Here's an XY axis. You don't have to write this down. I'm just going to show you. This is 0. We have to get to 300 degrees. That means we're here. That needs to be 300 degrees. But this opening here would be 60, right? 300 plus 60 gets me to the 360. I don't even care about those. I want to know, this is going to be my reference line for the last one, which is pointing down. But I can also use it above to help me come up with an arrow that goes in this direction, down and right. If I look at this opening here, how many degrees is that going to be? How much is it from here to here? Okay, so you've got 90 plus another 60. So how much is that? Okay, so take your protractor, turn it sideways like I am, and place the origin at the tip of the vector we just left off with, and line up the one we just drew with that 0 mark and the 180 mark. We can line up that line that we already have. Line that up. Now, we just said we need 150 degrees from the vertical, from up here. So from here to here is 90. There's 100, 110, 120, 130, 140, 150. Make a mark there. Okay, now how long is it going to be? 25.0 meters in this scale would be 5.0 centimeters. So we're going to start here, going in the direction of that dot to 5 centimeters. We add the arrowhead so we don't add length. We label this 25.0 meters, comma, 300 point degrees. We're going to erase that mark we just made as our reference. Now we can draw on our displacement, which goes from where we started to where we ended up right here. Connect them with your ruler. We had an arrowhead going to the end point. That is the displacement that we need to figure out. What is its magnitude and direction? So the first thing we're going to do is figure out the magnitude by measuring the length of it. I'm getting 10.0 centimeters. Getting about that? Okay, in this scale, 10 centimeters, 10 times 5 is 50, but I got to keep the precision. So this would be 50.0 meters. You're given 2/10 of a centimeter. So that means I'd allow you 1 meter of leeway. So anything between 49.0 and 51.0 meters would be accepted. Now I got to come up with the direction. We are going to ignore the 3 arrows I drew in pencil. We're only going to look at this arrow pointing down and right, and the angle I have to quote starts at the positive x and rotates around counterclockwise. That's the angle you have to measure. But we're not going to measure that whole thing. I know from here to here is 180 degrees. So all I'm going to do is measure this bottom arc by turning my protractor upside down like this. And I know that if I start here's my 0 now. 0, 10, all the way to 90. Then there's 100, 110, 120. I'm getting 122 degrees. So if this amount is 122 and that's 180, I get my answer by adding those up. 180 plus 122 gives me an angle of 302 degrees. Remember, you're allowed 2 degrees of leeway on that answer, and this would be plus or minus 1 meter. This is my final answer, so that's what I'm going to circle. Any questions? All right. Your homework, as I said, for Monday are the next 3 pages, 7, 8, and 9. On page 9, I need you to make a note. This one is use a ruler and protractor only. That is the only way you are to answer question 14. It's all drawing. Okay. One more thing I want to talk to you about is your tests that you took 2 days ago. I'm going to hand these back, and then I want to talk to you about how test corrections are done. This is how they're done for every unit test. Let me hand it back, and then I'll explain how test corrections are done. Actually, let me talk about the test corrections first, because once I hand that back, you're not going to listen. If you are eligible to do test corrections, it's because you missed a multiple choice question, or 2 or 3 or more. You'll have one of these correction sheets stapled to your test. That's how it's always done. Let me explain what you're going to do. If you have one of these stapled to your test, you have to write your name on it. Your class period is 5, and you absolutely must get a signature from a parent or guardian. This is the only way you get extra credit in this class, is by doing this, or lab corrections. Without this signature, I do not look at your corrections. You get no points back. There are 3 things you need to do for each question you missed on this sheet. You have to tell me what question it is that you are correcting. You have to tell me what the correct answer letter should have been, A, B, C, or D. And now, over here, this is the most important part. Why is the correct answer the correct answer? How do you get the correct answer? What should you have done to get the correct answer? You have to show your work or explain fully. If all you do is tell me what the correct answer is, you get nothing. Nothing back. You want any points back, this is what I'm looking at. And if this is wrong, I will not give you the points back. You can't correct constructed response. Now, what happens once you've done your corrections? Once you've done your corrections, you have to get them done by next Friday. You get 1 week on the calendar to do it. When your test corrections are done, you need to make sure that this is stapled to the answer sheet and the test booklet. Otherwise, I won't know what test version you had and what question it is you're correcting. This is signed. It's all stapled. Where you're going to put it, you will not hand it to me. You hand it to me, I put it in here. I don't even look at it. Where does it go? It goes in this bin right here. This is my turn-in bin for test corrections. I will collect them next Friday. I will not look at them in the meantime. Once you've got it done, you can put it in, but it has to go in there by next Friday. I will not ask for them. It will be on Google Classroom, but I will not ask for them in class. So if you want those points back, you get half points back. So each multiple choice was 5 points. So if you correct 1, you can get 2.5 points back on your test and so forth. All right, questions? All right. I'm going to hand these back. Monday, we will be finishing lab 4 after we take our quiz on distance and displacement and going over the homework. It is imperative you look over your test, particularly the show work where you can't get points back. to make sure you understand what I'm looking for. Without paying attention to directions, you're costing yourself points on every test that you cannot get back. Have a good weekend, folks. Make sure you push your chair. Have a good weekend.